Hello. I kind of wanted to show you guys something that some people might be missing a little bit from the videos that we are showing, and I just want to break it down for you guys, so you're not like super confused about anything. I wanted to draw you a couple things. So we're talking about sediment and the sizes of the sediment, so the sediment particle sizes. And I want to talk about specifically sand, silt, and clay. Sand, silt, and clay. And so I want to imagine, and you guys can imagine with me, and I'm looking right here. I'm trying to do like one, two, three. So I'm gonna try to draw something that looks kind of like one, two, three, like a test tube. Like we're in science class. It's a test tube, right? Okay, and inside of test tube, I know this one doesn't have so many fun colors, but let's say this one is going to be, this one will be sand. So this is going to be our largest one. It's going to move it, but I don't care. This one's going to be sand. It's going to be our largest particle. Sometimes they include pebbles as well. If this is going to be, and I'll show you, I'm going to like zoom over here. If this is going to be this, oops, wrong one. Oops, oops, there. If this is like a rock, then a pebble would be like that big. So because of that, I'm not really including it because I'm not even sure it would fit in a test tube. So that's going to be like our sand. Okay. So pebbles are rocks, are large, big chunks of rocks. You might say like gravel might be like a pebble. It's big enough, big in your hand. Sand is, tiny, but compared to silt and clay, sand is ginormously huge. So what we're going to do is, this is not obviously to size because you wouldn't probably be able to zoom in with your eyeballs so well without a microscope to see sand particles, but I'm just going to like give you an example of what it would be like, okay? And maybe over here as well, I'm going to draw a second one, two, three. Test tube. Wow, I teach science and my test tubes suck. All right, and the third test tube. So we're doing sand, silt, and clay. Fabulous. So here is going to be sand. So remember, sand is the largest particle. And because it is the largest particle, we might want to make this one just like already, like automatically quite a bit larger. Then you don't have to see my fabulous drawing skills. Now let's make it big. That's good. So let's see how that is. Yeah, it still needs to be bigger, actually. All right. Yeah, that's more like it. So inside of this test tube, we're going to go ahead and I'm going to try to like make some sand happen. Ooh, hi sand. That is the worst test tube I have ever seen. I would return it from whence I got it. So sand, 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 lots and lots of sand. So if you're filling this thing up, sand. Okay, no problem. We got sand here. Now, what we're going to be playing with, though, is what if we were to pour in water? So the thing I want you guys to be thinking about is right now, as these irregular shaped things, so like sand itself, if you've ever really looked at sand, like even under a microscope, sand isn't actually round. It's actually kind of like broken, jar. I mean, like it could be kind of square shaped. They're not at all a regular shape of a circle at all. So when you put them together, they don't really fit well together because they are very irregular sized things. Like that is more like sand, to be very honest. And because of that, look at all that space. It's kind of like if you had a bunch of tennis balls and you put them in a bucket. They don't fill the entire bucket. Okay, it's not made of jello or pudding or water where it fills every bit of the bucket, where it fills the volume, the space. It doesn't. When you put tennis balls in there, they keep their shape and they allow for like water or in this case air to come between them. Okay, which makes sense. If you were going to put a hose of water into a bucket of tennis balls, you would actually be able to fill up quite a bit of water in between there because there's a lot of space, there's a lot of air in between where the tennis balls kind of touch, but then there's all that extra space there. Kind of makes sense. If you haven't tried it, go ahead and find some tennis balls. Get them from your family, whatever. I don't know. All right. So what I wanted to demonstrate though is in nature though, we're not talking tennis balls, we're talking sand, which are these crazy irregular shapes right here. And why this is important for erosion is if like water or air can get in there and break it apart and send it away pretty darn easily. It's like, well, probably. Okay. So I want to see if I was going to pour a bunch of water in here, would I be able to get like a ton of water in here? Well, looking just right here with all this extra airspace, I mean, I know I didn't finish it perfectly, but there's still a lot of airspace that like water could go through and fill up. No problem, water's going to fill up. It's going to go down there. It's going to go everywhere in there. It's going to be some over here. So there's a ton of airspace here. Oops, I went over one. Of airspace here that absolutely water would be able to sneak into those air spaces and fill it up. And so you would imagine since there's so much air between them, these irregular shapes, like I can put like water in between here and I can put water in between here. If they were like perfectly like squared, I would not be able to put all this extra water in between the shapes, but because they are naturally different shapes and different sizes, that does allow for like there to be air or water to sneak in, right? So remember, this is like if they were perfectly squared up, there would be like no space. Oh, wow, I'm terrible making squares. There would be no space for the water or the air or anything else to get in there. They would just fit nicely, kind of like cute little like blocks or Legos. And then the water wouldn't be able to go anywhere. But because they are naturally irregular, we see this happening. So that is sand. Go away. All right, now let's do, I'm going to type it. This is going to be silt, S-I-L-T, silt. And this one is going to be our medium sized one. And I'm actually going to zoom a little bit in on this one so I can actually work a little bit better with that. All right, so we had this guy right here, and let's see. Let me think, let's go a little bit bigger. Yeah, I think we had like 6 last time, and that was like a little bit too large. Yeah, that's a little bit better. Maybe even bigger. That's better. Yeah, that's nicer. So this is sand, then this is going to be silt. So I'm not going to do the entire thing because I think I would just cry if I had to do the entire thing in here. Um, and I know I can't do this on Jamboard, but actually I like Awe, which is a collaborative whiteboard. If you guys have not used it, I am a big fan. It means you can send a link to people, and maybe if you're working in groups, they can all work on the same thing all together. It's pretty cool, pretty snazzy. You can work on the same picture or type things. It's very cool, very collaborative. Jamboard is too, but this one has a little bit more options when it comes to drawing and sizes and like all that stuff than Jamboard does have natively in there. So okay, I'm super bored. It looks like boba. I'm so hungry. So now going back here, so this is our silt, and silt is kind of the medium-sized one, and that's totally fine. But once again, we're looking here and comparing it to the open spaces in between there. This would be like if you had instead of tennis balls, if you had like I would say like golf balls, a little bit smaller, still not square, and they still don't exactly fit together. But you're a little bit less airspace available, and thus it'll be a little bit like less water space available. In just a second, but still is there air? Yeah, absolutely. There's space and air between them. Not as much space and air between as there is in the sand. But there is still some. Okay, it's not like watertight or airtight or anything like that, right? So now, just to like demonstrate silt, I gotta zoom in because I cannot do that like otherwise. We're gonna try to see like this one's so much harder because there are like there is air and space in between each of the particles. It's harder. It's harder to find a space, right, for the water to creep in, or there's a big space because I left a big space. Seeing here is like I'm kind of stuck. Maybe I don't know. That cheated. I cheated. All right, so water is still able to kind of come in here and fill up the air spaces, but not as easily because there is less. There's less space in between the particles. The particles are smaller, and so there's less airspace kind of given it to it in this one container inside of this ginormous test tube. So like less water, which absolutely makes sense. Like if you were dealing with like ping pong balls or golf balls versus tennis balls in the same bucket, exactly same container, and you're pouring water in, you could get probably double the amount of water into the one with the tennis balls because there's probably double the amount of air space in between the particles because they don't fit together. This one would probably have maybe half as much. Now for our last one. And this one's a cool one. This one's clay. Clay, clay. I like clay. It's fun stuff. And this one I'm going to keep at one, and there's a reason why, but I do need to kind of zoom in a lot and actually pan over. Woo! Hi, move with me. All right, so this one's going to be a little bit weird because, well, clay's a little bit funny. Clay's a little bit funny. So I'm going to make sure it's in the smallest one possible, and I'm going to try to draw this. So the cool thing about clay is its shape isn't irregular, quite like the sand, and it's not even really roundish. It's more like, it's like a paper plate. It's plate-like. It's flat, and it's kind of rounded. So it'd be kind of like you had like little discs, right? Like a frisbee. Ooh. Yeah, frisbees. Lots of little frisbees are like paper plates. Yay. This is harder to draw than it seems. So remember, clay is plate-like. We sometimes call it platey, which is actually a true scientific term. Just sounds ridiculous. All right. Wow, that's a terrible plate. Kind of pancake-like. Ooh, pancakes. Fabulous. All right. I'm gonna lose my patience pretty quickly. That was a terrible pancake. You're not good at Miss Steve's restaurant. She don't know how to make pancakes. I do know how. Oh, that's a terrible. All right, whatever. All right. So here we are. And this one, there is a reason what's going to happen. We're going to dump all this water in here and look at the space in between there. Now, is there still space? Absolutely. Even compared to the other ones, there still is space, but the problem is because of the shape of the clay. Here, let me zoom more out. We're gonna have more problems getting in between there. And not only in between there, but for the water to show up from here. Oops, let me draw from here up on top to go through all the way to the bottom, it's going to be way harder because actually it's going to run into like almost like walls, which is maybe some of it can make it through. Nope, ran into a dead end. Let's see. Maybe this guy right over here can maybe make it. It's like a maze. We made it out. It's going to be much harder because it is literally going to find almost like a brick wall because those plates actually do in nature, truly, they stack up one on top of another. And in effect, it like walls off the other things. So very little of the water is actually going to be able to make it through down into here. It will eventually because they're not perfect and there are going to be, we're talking tiny things that are hard to see with your eyeball because to us, these things just look like dust, like dirt. Um, if it's got water, if it's in water, sand, silt, or clay, we say that they are suspended. There's something called a suspension, and that's suspended. These are materials that are suspended in water. So when things are suspended in water, it means often they're carried along with water. You can consider that like mud. So sand, silt, and clay goes together, and it makes what we consider to be soil. You might also consider pebbles, like larger rocks, to be that. Also, there's going to be something, maybe some organic material. Organic means things that come from living things. So organic things from living things. So when we say organic, it's a little weird when you're like organic food. I'm like, isn't all food organic? I'm like, well, yes, but some of the pesticides we use are not. Some of the stuff to keep the bugs and maybe it growing are not, absolutely are not. So organic's a little weird when it's food, but when it comes to science, we're like anything that is from an animal. So you are organic. Your cat is organic. Your hair is organic. Corn is organic. Leaves that fall off of trees and go break down into bitty bits and then join the soil. That is organic. A raccoon that dies in the woods. That is organic and it becomes part of the soil. like the circle of life, that kind of a thing. So when we're talking about organic stuff, we include that as well. So we have lots of different things going into soil, and depending on what it's made of, and maybe how much air or water can come through it, depends. How far water can move it, how far air can move it. Also, like how healthy a soil is it? If I only have rocks and I'm trying to grow like a tomato, I probably can't because they actually need to have soil, which is like not just rocks. Same with like sometimes just like pure like living organic stuff. You need a little bit of heavier stuff sometimes actually to grow like tomato plant. You do need some sand in your soil. If it's all just like, you just try to grow a tomato plant out of like a dead rotten raccoon, probably not going to work. Who knows? It might. That'd be a cool science experiment. Don't kill any raccoons, but if you find one, go for it. So yeah, so about soil, sand, silt, and clay. Those are the basic sediments that we talk about. Sometimes they talk about other ones, larger ones, or maybe even smaller ones, but these are three basic building blocks. And that's pretty much going to be it. The three basic building blocks that make up dirt, that are sediments that are in our ground, in our dirt, in our soil. And as we were watching videos on dam removal, we saw all of these things being carried along by large gushing bits of water. Okay. So it's something to think about. As water is applied to these things, what do we find happening? Well, this is what we find happening.